This video we're going to be talking about rate of change, which is also known as slope. So we're going to look at various ways of calculating slope. Example 1. The graph shows the average fuel efficiency for an older sport utility vehicle, SUV, and a new smart car. So smart car and SUV. We have the volume of fuel used versus how far it's gone, so the distance driven. Which car is more fuel efficient? So if it's more fuel efficient, it's going to take less fuel to go further along. So less fuel per kilometer. So as you know, rate of change or slope, or you may not know, but it's basically going to be the change in our dependent variable over the change in our independent variable. So in our case, in this specific case, our volume is our independent and our distance is our dependent. We know that from the scenario, but we also know based on the graph, because our independent is always on the horizontal axis and our dependent is always on the vertical axis. Okay. We also can talk about rate of change as rise over run. What does this mean? Rise is up and down, so that's dependent, and run is left and right, so that's our independent. And sometimes we see this in a formula which is y2 minus y1 over x2 minus x1. What does this mean? As you remember, usually our independence x and our dependence y. Okay. So if I were to look in a change, let's use these 2 points for the change in the smart car. Draw a triangle just to see the change in the independent versus dependent. So this is my rise, my dependent. So this point here is 8 and 192, and this one is 15 and 360. I'm going to do 360, because that's where that is. Subtract 192 to get that change. Okay. And here is going to be the distance between the independent, which is 15 and 8. So I'm going to do 15 minus 8 to get that change. Okay. So for our smart car, our slope or rate of change is equal to our rise over run. So our rise is the change in the distance that went up and down, so it's 360 minus 192, so it's 168. And our run is 15 minus 8, so that's 7. I know it's a positive direction, so it's good if my slope is positive. That means I did something right. I can write the units in to help me with the final statement. So 168 divided by 7 is 24 kilometers per liter. So that's how many kilometers I get per liter with the smart car. Now let's compare it with the SUV vehicle. So let's use the 2 points highlighted. So this point here is 144, 16 and 144. And this point here is 8 and 72. You know that by the scale. So remember, our rise is the change from 144 and 72. That's 72. And our run is the 16 minus 8, which is 8. So we'll put that into our slope. So now we did the smart car, now we're going to do the SUV. So remember, slope and rate of change mean the same thing. So it's rise over run, so vertical divided by horizontal. And we're talking about the change in the value. So 72 divided by 8. Writing in the units helps with the final statement. So this is 9 kilometers per hour. Per liter, sorry. So we're getting 24 kilometers per liter with a smart car and only 9 kilometers per liter for the SUV, which means that the smart car is more fuel efficient. The smart car is more fuel efficient because you get more kilometers per liter. All right, so look here, more examples. Remember, again, slope is rise over run. Okay. Determine the rate of change of each of the following lines. Draw a rate of change triangle. So, when you want to do rate of change, you can pick any 2 points. Because in a line, the rate of change is going to be constant. I'm going to make a triangle here and here. So remember, this is my rise, this is my run. That's the formula for slope, rise, or run. Okay. So I can either look at how much it's changed from here to here. So it's gone from 1 to 5. So 5 minus 1 I know is 4. And then from here it's 2 to 0. So I know that's 2 minus 0 is 2. So I sub them in like that. 4 over 2, which is 2. Or I can use a different type of formula, which we mentioned earlier, which is y2 minus y1 over x2 minus x1. So x1 and x2, I'm going to write down the 2 points that I've selected, which are these, which is 0 and 1, and 2 and 5. So this is x1, x2, y2, sorry, y1, x2, y2. So I do y2, 5, minus 1, and 2 minus 0. So this helps us if we don't have an actual visual graph. I can simply just use this formula. That gives me 2. Okay, so the next one, again, if you have a graph, you can use any 2 points and draw a triangle. I use these 2. Remember, it's rise over run. Rise, we're going from 0 to 6. That's 6, but we're going down, so it's going to be -6. Downward lines have negative slopes, and this is from 1 to 3, so that's a difference of 2. So I get -3. That's my rate of change, also known as slope. So again, any 2 points on your line. Let's keep practicing these. You want to pick clear points. Use these 2. So again, rise here, I'm going from 3 to 6. And here I'm going from 4 to 10. That's 6. So my rate of change is rise over run. I've risen 3 and I've run 6. So my rate of change is going to be 1/2. Okay. You can write down the points and look at your graph. So here we're going from -20 to -10. It's going upwards, so it's going to be positive. It's increased 10 because it's gone from -20 to -10. And from here it's from 0 to 12, so that's 12. So rise over run is 10 over 12, which is 5 over 6. Okay, and the last example I'm going to go through. Given 2 points, find the slope by graphing the points and drawing a rise over run triangle. Show your work. So here we're given 2 points. 1 and 5 is 1 and 5. 9 and 7. That's my line. Just gotta fix it a little bit. Oops. And I'm going to draw a triangle with those points. Let's think about how much this has changed. So this is 1 and 5 and 9 and 7. We can use the slope formula, or we can look at the change. So we went from 5 to 7. That's 2 numbers. So 2 numbers here. And we're going from 1 to 9, so that's 8. Okay. So our slope is going to be, also known as rate of change. It's going upwards, so it's going to be positive. 2 divided by 8. So you notice they don't have to be whole numbers, they can be fractions, they can be decimals, they can be positive, they can be negative. Negative ones just give us direction. And lastly, I'm going to go -6 and 0. And -4 and 8. Still a positive slope. Now we just have to think about negative numbers. Okay, so I'm gonna draw my line. Okay, go like this. Okay, so let's think about it. We've gone from 0 to 8. So that's 8. Looking at my horizontal, my vertical. Then I've gone from -6 to -4. When I get less negative, I actually increase. So I've gone up 2. So my rate of change, also my slope, is rise over run. Remember, rise is vertical, run is horizontal. 8 divided by 2, which is 4. And there you have an introductory to slope and rate of change.